In part 3 of section 10, we're going to be looking at some matrix arithmetic. Definition 10.4 is going to define for us the sum, the difference, and something called the scalar product for matrices. Now it begins the definition with saying let A and B be matrices. So capital A and capital B are supposed to represent matrices, specifically of the same order m by n. So you cannot perform the operations that we're describing here with multiple matrices if they are not the same size. They have to be the same order in order for this to work. And if we see little c is going to be representing a real number. So number one, it says the sum, also known as a plus b. Now the result of adding two matrices together is that you'll get another matrix of the exact same size. So it says here the sum a plus b is the m by n matrix obtained by adding corresponding entries of a and b. So you're supposed to go to each location, each row and column for A, and go to each row and column for B, and then you'll add up whatever values you see there. Then you go to the next row and column and do the exact same thing. If you do that for all of the potential entries, every row, every column, then you will create this new matrix that we call A plus B. The difference is really done similarly, where we call it A minus B, and the result of A minus B will always be a m by n matrix. So it's going to be a matrix of the exact same size you started with, and you get this by subtracting corresponding entries of A and B. So again, it says go to the row and column that is matching in A and B and perform your subtraction there. And the last operation I want to discuss is the notion of scalar product. So this is not going to be taking two matrices and multiplying them together. That's known as matrix multiplication. What we're doing is scalar multiplication. Back here at the top, when we talked about C representing a real number, that means that C is a scalar value. So we're going to be using this scalar value as a multiplier. And it says here CA, or C times A, is the operation, and it is represented as another m by n matrix. So the matrix never changes size whenever you perform the operation. And the way that you will create this new matrix is by multiplying each entry of A by your scalar value. Basically, it's just distribution. So we will be able to do three operations with the matrices: a summation of two matrices, A plus B, the difference between two matrices, A minus B, and then the scalar product between a real number or a scalar value and a matrix.